In this video, I'll be going over the solutions for the short answer section for the post-test revision. So question 1 wants us to factorize this particular trinomial. So in this case, we're trying to use the product sum method. So find two numbers multiplied together that adds up to -3, okay? So in this case over here, it's going to have something to do with 5 and a 2, but we're trying to get it to -3 when you add them together. So it makes sense, it's going to be -5 and you add it with +2 in this case, okay? So therefore, if you're going to be writing this, then it's going to be x minus 5 x plus 2, and we're going to leave that as our answer. We don't really need to solve for it because the question just wants us to factorize. Question 2 again wants us to factorize it. So again, find two numbers that multiply that gives -15 but adds up to give -2. So in this case over here, it's going to be let's see, -5 and +3. So it's going to be x -5 and x plus 3, and you can always double check this again by using the fold method to expand to see whether it gives the original equations. Question 3 wants us to solve it using the null factor law. So the null factor law states that when you've got two binomials that are multiply each other, two factors, then each one of them could either equal to 0 or both of them could equal to 0. So what you simply do is you equate each of the factors to 0. So in this case, x is going to equal to 0, or alternatively, you're going to have x plus 2 that's equal to 0. And if that's the case, then that would imply that x would equal to -2. So your solution is x is equal to 0 or x is equal to -2. For part B, you're going to equate again each of these to 0 and solve for x. So it'll be x is equal to -3 as a result, or x is equal to 2. I didn't really show any working out there because I'm scared that I don't have enough space. And for part C, what you're going to do is you're going to solve for x, okay? So if in this case, if you're solving for x, then it's going to be 4x squared is equal to 9 by moving the -9 to the other side by adding it. And what you do afterwards is you divide both sides by 4. So it'll be x squared is equal to 9 on 4. And in this case, because we're trying to solve for x, we'll take the square root of both sides. And because you're square rooting a positive number, you have a positive answer as well as a negative answer. So therefore, it's going to be 3 on 2. Or x is going to equal to -3 on 2. Alternatively, you guys could have recognized that this was a dot, and you could have just done it like something like this instead. You could have done 2x plus 3, 2x minus 3, and that's how you would factorize it as a difference of perfect square. And therefore, again, you would just go x is equal to -3 on 2 if you do this one, and this one will be x is equal to +3 on 2, okay? And that's just another way you could answer that question. For question 4 over here, we'll use the product sum method to factorize, and then we'll use the null factor law. So two numbers are multiplied to give you +21, but -10 is going to be -7 and -3. So it'll be x -7, x take away 3 is equal to 0. Therefore, x is equal to +7, x is equal to +3. And make sure you include the word or in there. After that, for part B, do the same thing. So find two numbers that gives you -36, but adds up to give you 5. So in this case over here, it's going to be x plus 9 and x minus 4 is equal to 0. Hence, x is going to equal to -9, or alternatively, x is equal to +4. Let's move on to part C. So for part C, do the exact same thing again, but this time, what we're going to be doing is we can't be using the product sum method. What we'll just do is we'll just solve for x, okay? So just by using normal algebra and using inverse operations. So what we'll do is we'll divide both sides by 3. So if you divide both sides by 3, it'll be x squared is equal to 9. And hence, you take the square root of this. X is going to either be equal to +3 or x could equal to -3, because -3 squared also gives you +9. For part D, what we're going to do is we have to actually move all these terms to the left hand side, and by moving it to the left hand side, you're going to get a trinomial which you might be able to factorize using the product sum method. So if you move 4x and 5 to the other side, your equation should now look like x squared minus 4x minus 5 is equal to 0. And in this case over here, we can factorize it using the product sum method. So it's going to be x -5 x plus 1 is equal to 0. Hence, x is equal to +5, or x is going to equal to -1. And for the very last one over here, which is worth a bit more marks than the other questions, what you need to do is similarly like question D, move everything to the same side for you to actually factorize it using the product sum method. But in this case, this involves a bit more steps because you got to expand it and then collect like terms before that. So in this case over here, I'm just going to expand everything on the right hand side, sorry. So it'll be x squared minus 3x. Move everything on the right hand side to the left hand side. So if you do that, then it's going to be x squared plus 3x minus 28 is equal to 0. So in this case here, again, what we're going to try to do is factorize this. So this would be x plus 7, x minus 4 is equal to 0, because positive 7 minus 4 gives you positive 3, and you multiply these two, it gives you negative 28. Use null factor, hence x is equal to negative 7, or x is equal to positive 4. For question 5, this question wants you to complete the square. So in this case over here, if we're completing the square, then completing the square involves us finding the value of b, halving it, and then squaring it. So this over here was the formula, and what we're doing is we're going to be introducing this term into our equation in order for us to complete the square. So in this case, if I substitute b inside, it will be 6 on 2 whole squared. That's the same thing as writing 3 squared, which is equal to 9 in this case, okay? So what we're going to do is we're going to add 9, but also we're going to subtract 9 at the exact same time as well. And the reason why we're subtracting it is so that we don't try to change the actual equation itself, so that the equation remains balanced. So therefore, in this case, it's going to be x squared plus 6x plus 9 minus 9. And then I just write whatever's remaining plus 7, okay? So what I did over here was I added 9, but then I subtracted 9 because 9 subtract 9 is equal to 0. So I haven't actually changed the equation. But what I can do now is I can factorize the first 3 terms as a perfect square trinomial. So therefore, it's going to be x plus 3 whole squared, and negative 9 plus 7 is equal to negative 2, equals to 0, okay? So now that I factorize it, what I'll do now is I am going to solve for it in this case. So if I was to solve for it, one of the ways I could go about this is by factorizing it as a difference of perfect square. So I could write it as x plus 3 plus root 2 and x plus 3 minus root 2. Now, if you're wondering how did I get this, then that's this equation over here is the same thing as, it kind of resembles a dot, and hence all you need to do is find the values of a and b and substitute that into the formula a plus b bracket a minus b, because that's what the general formula of a difference of perfect square is. So that's what I've done over here to get that answer, and hence I could equate each of these to 0 and use a null factor to solve for it. So hence x is going to equal to negative 3 minus root 2, or x is going to equal to negative 3 plus root 2. Okay, so that's one of the ways you can go about it. I'm going to show you another method. So from here, again, you could also just move the 2 to the right hand side. So you can go x plus 3 whole squared is equal to 2. Take the square root of both sides. So therefore, you're going to have x plus 3 is equal to root 2, or x plus 3 is equal to negative root 2, okay? Because you can have the positive solution as well as the negative solution. And then for just move 3 to the other side, hence x is going to equal to root 2 minus 3, or x is equal to negative root 2 minus 3, okay? And again, that's the exact same answer as this over here. Just choose whatever method that suits you. And for part B, it's asking you to find what the turning point is. Remember that by completing the square, this actually allows us to find out what the turning point is. So when we were completing the square, we had this part over here, and this is already in turning point form. So therefore, our TP, in this case over here, is going to be negative 3, negative 2. Now for question 6, again, it wants us to complete the square, and in doing so, you should be getting this as an answer, okay? So in this case, we'll just find out the value of b, half it, and then square it. So b half of that squared. So therefore, b in this case is equal to positive 4. So 4 on 2 squared, that's equal to 2 squared, which is equal to 4. So introduce this term. So it'll be y is equal to x squared plus 4x plus 4. And you want to subtract that again so you don't change the equation, because these two equals to 0. And now what you're going to do is you're going to factorize it as a perfect square. So it's going to be x squared, x plus 2 whole squared, and that's going to be minus 9 equals to 0. And the reason why I made it equal to 0 is because we're trying to solve, sorry, we're not trying to solve for it. We're just going to write this as y is equal to x plus 2 whole squared minus 9. And as you can see, that is our answer over here. You would equate the y to 0 if you were actually trying to solve for it in this case. And for part B now, part B wants you to find state the coordinates of the turning point. So this is already in the turning point form. So hence you're going to write your answer as TP is equal to -2, -9. And lastly, what you're now trying to do is you're trying to find the coordinates of the x-intercepts. So what I was trying to do in part A earlier, will be x plus 2 whole squared minus 9 is equal to 0. And what I've done is just sub y is equal to 0 to solve for the x-intercepts. What I'm going to do is I'm going to show one of the ways that you can actually solve for x. So what I'll do is I'm going to just move 9 to the other side. So it's going to be x plus 2 whole squared is equal to positive 9. Take the square root of both sides. So it's going to be x plus 2 is equal to positive 3. Or you're going to have x plus 2 is equal to -3. Move 2 to the other side by taking 2. So therefore, it'll be 3 minus 2 is equal to 1. Or x is going to be -3 take away 2 is equal to -5. So those are the your x-intercepts, positive 1 and -5. Let's move on to the next question. So for question 7 over here, it wants us to sketch this graph by showing all relevant points. So we need to show the turning point, we need to show the x-intercept, the y-intercept as well. So in this case over here, because it's already in the turning point form, that's the most easy. So turning point is therefore equal to -2 and positive 4. Now to find out the y-intercept, sub x is equal to 0 to find the y-intercept. So it's going to be y is equal to -0 plus 2 whole squared plus 4 in this case. 0 plus 2 is 2, 2 whole squared is 4, and because it's a negative sign, it's going to be y is equal to -4 plus 4, and therefore the y-intercept is going to be where the origin is, okay? And to find out your x-intercept, what you'll do is you'll sub in y is equal to 0 and solve for it. So I'm going to do that here. -x plus squared plus 4 is equal to 0. What I'm going to do is I want to move 4 to the other side, so it's going to be -x plus 2 whole squared is equal to -4. Because you've got a negative in front, I'm going to divide both sides by -1, and that will just get rid of the negative signs on both sides of the equation. Now that I've got two positive terms now on each side, I'll now take the square root to solve for x. So therefore, it'll be x plus 2 is equal to positive 2, or x plus 2 is equal to -2, because the square root of 4 could either be positive 2 or -2. And move the positive 2 to the other side. So there'll be x is equal to 0, or x is going to be equal to -4, okay? Now that I've got all of the relevant points, I'm going to now plot that. So -4 lies over here. This is where your y and x-intercept lies as well. And your turning point was at the value -2 and +4. So that's going to lie somewhere around over here. And all I'm going to do now is just connect the dots. So you're going to have an unhappy face parabola. And the reason why you're having an unhappy face parabola is because, as you can see here, your A value is a negative value, which indicates a reflection. That's why you will have a maximum turning point. After this, make sure you are labeling your intercepts. So 0, 0, that's -2, 4, and this one over here is going to be -4, 0. All right, let's move on to question 8. So question 8, same process. It's already in a turning point form. So your turning point for this question is going to be -3, -8. To solve for your your y-intercept, sorry, you will sub x is equal to 0. So it's going to be y is equal to 2 bracket 0 plus 3 whole squared minus 8. So in this case, 3 squared is equal to 9, and 9 times 2 is equal to 18. So y is equal to 18 minus 8. Hence, your y-intercept is going to be 10. Okay, so this over here is going to be the coordinate for your y-intercept. And now what we'll do is we're going to solve for x. So we'll sub y is equal to 0. So it's going to be 2 bracket x plus 3 whole squared minus 8 is equal to 0. Move the 8 to the other side. So if you do that, then this is what your equation would look like. Divide both sides by 2. So it's going to be x plus 3 whole squared is equal to 4. Take the square root of both sides. So therefore, you're going to be left with x plus 3 is equal to +2, or it'll be x plus 3 is equal to -2. And then what you do is you just subtract 3 from both sides to solve for x. So hence, x is equal to -1, or x is going to equal to -5. So in this case, let's include all of our coordinates. So -5 lies over here. Your y-intercept was, where was it? +10, so that goes over here. And your turning point was -3, -8. So that's going to lie right over here. So now we'll just connect the dots. So if you do that, then this is what your graph should look like, and try to make it as symmetrical as possible. And now what we do is we're going to include the coordinates for our intercepts. My hand slipped over here, but you guys should draw a much better version than me. -5, 0. This is -3, -8. And this one over here is going to be -1, 0. We don't need the extra line. And this is going to be 0, 10. All right, next question. So you've got an extra 2 more graphing questions over here. And for these graphing questions, this time it's now expressed in the standard form. And when it's in standard form, I think it requires a little bit more working out, but it's not too complex at all. So in this case, when it's in the standard form, you can only really find the y-intercept readily. So your y-int is going to be equal to 0, 16. That's the value of c. To find out your x-intercept, what you could do is you could factorize it, you could complete the square, or you could use a quadratic formula. I personally recommend you don't try to use quadratic formula straight away. Try to factorize it if you can, and then if you can't, then use a quadratic formula. Since factorizing it just by recognition and using the product sum method is just a lot more efficient and more faster. So in this case over here, can I factorize this? Are there two numbers that go into 16 but add up to 8? In this case over here, yes, we do. It's going to be y is equal to x plus 4 whole squared, essentially. Okay, so therefore, if I'm going to solve for x, I'll sub y is equal to 0. So it's going to be x plus 4 whole squared is equal to 0. And therefore, if you equate this, it'll be x plus 4 is equal to 0. Hence, x is equal to -4. And you'll only have one x-intercept because this is a perfect square. Okay, all perfect squares will always have one solution. And last thing I'm going to do now is just find out what is my turning point. So in this case over here, to find out your turning point, you could use the formula, TP is equal to -b on 2a. So if you do this, -8 on 2 is equal to -4. Okay, coincidence, that's your x-intercept. And what we'll do now is we'll substitute that into our formula to find out what is the corresponding y value. So if you do that, then it's going to be y is equal to -4 squared is equal to +16. -4 times 8 is equal to -32. And your +16, which in this case is going to get equal to 0. So therefore, your TP is going to be equal to -4, 0. And you should have already been able to identify that based on this equation of here, because you should recognize straight away that the only difference from that equation to y is x squared is just a horizontal translation to the left hand side. So in this case, if you were to graph your equation, we said the y-intercept is 16. We can't really show that on this graph over here. So if you could, then this over here is what your graph would actually look like. So I'm just trying to sketch it. Okay, so something along the lines of that if you had the actual room for it as well. So therefore, label the coordinates if you can. And that's what our graph would look like. All right, so I'm hoping for question 10, I also have enough space to graph this particular parabola. So again, do the exact same process. Can you factorize it? And if you can factorize it, then use the product sum method. And then otherwise, if you can't, use a quadratic formula. So in this case, are there two numbers that multiply with each other gives you -8, but adds up to -2. In this case of here, there will be. So it's going to be y is equal to x minus 4x plus 2. Okay, so I factorize it, so therefore I can find out what is my x-intercept quite readily. It's going to be x is equal to 4 or x is equal to -2. Okay, so I found out my x-intercept straight away. I could find out my y-intercept. So my y-intercept is going to be, in this case, -8. So 0, -8. And to find out my turning point, I've got two options. I could either find the midway distance between my x-intercepts, okay, so find out the average essentially, or I could use the formula. In this case, because I got my x-intercepts, it makes sense for me to just to use these two values over here. So in this case, find out the midway distance, so just add them together and then divide by 2. Okay, that's how we normally find averages. So therefore, in this case, 4 take away 2 is equal to 2. 2 divided by 2 is equal to 1. So that's the x value of your turning point. So sub x is equal to 1 into the original equation. So if you do that, it will be y is equal to 1 squared minus 2 times 1 minus 8. That's y is equal to 1 minus 2 minus 8. So in this case over here, you will have y is equal to negative 9 in this case. 1 take away 2 is negative 1, negative 1. Yep, sweet. So therefore, your turning point is going to be TP is equal to 1 comma negative 9. Sorry for rushing it, but that's what our turning point over here is going to be. So let's plot our coordinates in. So x is equal to positive 4, x is equal to negative 2. Our turning point we said was 1 comma negative 9, so that's going to be lying around here, and our y-intercept is going to be where negative 8 lies. So therefore, connect the dots together. So if you guys have done this successfully, then this is what your graph should look like. Okay, I kind of went off from this x-intercept, but it's a bit hard to draw on iPad, but you guys will do a much better job than me. So it'll be 4 comma 0. This is going to be 1 comma negative 9. Y-intercept is y0 negative 8, and this is negative 2 comma 0. Sweet. Let's move to the next question. Question 11 wants you to find the quadratic rule for the following parabola in both the turning point form as well as the standard form. Because this particular graph over here kind of gives you the grid lines, we can therefore readily identify and very accurately what is the actual turning point in this case. So in this case over here, your turning point looks to me it's going to be negative 2 and positive 2. And since we know what the turning point is going to be, therefore it makes a sense that we can express this in the turning point form. Just a reminder, the turning point form was y is equal to a bracket x minus h whole squared plus k. So now that we know the turning point, let's substitute those values into h and k. So it's going to be y is equal to a bracket x plus 2 whole squared plus 2 as well. Now that we've got this, we'll therefore substitute another coordinate into the actual equation to solve for a in this case. So in this case over here, I can clearly see that the parabola passes through this particular coordinate, which is negative 1 and positive 5. So therefore, if I substitute that in, I can therefore solve it. So I'm going to do that right now. So therefore, it'll be 5 is equal to a bracket negative 1 plus 2 whole squared plus 2. If I simplify that, negative 1 plus 2 is equal to positive 1, and positive 1 squared is going to be 1 still. So it's going to be 5 is equal to a plus 2. A is therefore going to equal to 3 if you subtract 2 to both sides of the equation. Hence, therefore, your equation is going to be y is equal to 3 bracket x plus 2 whole squared plus 2. Now the question wants us to write our equation in the standard form, and in order for us to convert from the turning point form to the standard form, all we simply need to do is expand the brackets, as you can see here. So what I'm going to do is I'm going to expand this part over here. So it's going to be y is equal to 3 bracket x squared plus 4x plus 4. Sorry, that should be a 4 here. Plus 2. I'm now going to expand this, so it'll be y is equal to 3x squared plus 12x plus 12 plus 2, and therefore just collect the like terms. Hence, your final answer is going to be y is equal to 3x squared plus 12x plus 14. Question 12 is a very similar question, so do the exact same thing again. So in this case, your turning point corresponds to 2 comma 5. So if we substitute that into our turning point general formula, it's going to be y is equal to a bracket x minus 2 whole squared plus 5. What we'll do is we'll substitute another coordinate into the equation to solve for a. So in this case over here, I'm going to be substituting in that coordinate, and that coordinate corresponds to 1 comma 2. Okay, so if I do this, sub 1 comma 2 in, so it's going to be 2 is equal to a bracket 1 minus 2 whole squared plus 5. 1 subtract 2 is equal to -1, and -1 whole squared is just going to equal to +1. So it's going to be 2 is equal to a plus 5. Subtract both sides by 5, and therefore a is equal to -3. And this does make sense as we are having an unhappy face parabola. So therefore our answer is going to be y is equal to -3 bracket x minus 2 whole squared plus 5. And similarly, to get it into the standard form, I'm just going to expand the brackets. So it'll be y is equal to -3 bracket x squared minus 4x plus 4 plus 5. Expand the brackets. Y is equal to -3 x squared minus 12. Oh, sorry, that should be plus 12 minus 12 plus 5. And therefore, just collect that like term. So therefore, y is equal to -3 x squared plus 12 x minus 7. For question 13, the question 13 reads, the height h meters of a ball above the ground at time t seconds after it has been thrown is given by this particular equation up here. The first part wants you to find out how high is a ball above the ground when it's first thrown. So in this case, when it's first thrown, that's when t is equal to 0. So in this case over here, that corresponds to this particular height. Since this particular equation is already set up in the standard form, therefore this value here, the value of c, is going to give us what its initial height is going to be. So therefore, if you sub t is equal to 0, so sub t is equal to 0, therefore height is going to be 4 meters. And just make sure that you are including your units in the answer when you are dealing with like these application questions. Part B wants you to factorize that particular equation over there. Now, in order for you to factorize it, because there is a -1 coefficient in front of the t squared, I'll just factorize and take the -1 outside. So if you do this, it would be -1 t squared plus 3t minus 4. And now that I've got the -1 outside, I can therefore factorize this normally as I would using the product sum method. So in this case, find two numbers that are multiplied together that gives you -4, but adds up to give you +3. In this case over here, you'd agree with me that it's going to be +4 and -1. So therefore, if I factorize this is what I should get. +4, and that should be your answer over here. And now for part C, it's now asking you to pretty much solve for t in this case, like how you would normally do it, by using the null factor law. So in this case, if you were to use the null factor law, t is going to equal to -4, or t is going to equal to +1. But in this case up here, remember guys, when you're dealing with application questions, negative values don't really make any sense at all. So therefore, your final answer is going to be when t is equal to 1 second. And that's how you would answer this particular question over here. For question 14 over here, a very similar question. So you've got another throwing projectile motion question. Part A wants you to find out how high is the ball above the ground when it's first thrown. So again, it's asking for the y-intercept. So in this case, it's going to be 28, and this is also going to be meters because that's the unit provided. When is the ball at ground level? So again, if you were trying to model this up, this is what your graph would look like. So you're trying to find out what is the x-intercept. Okay, so in this case over here, we'll have to factorize this. So take out the negative first, or in this case over here, let's not factorize it. Let's actually use a quadratic formula just so I can show you how we could use the quadratic formula to solve this. So it'll be, in this case, t is equal to -3 plus minus square root 9 minus 4, -1, positive 28, all divided by 2 times -1, okay? So if you put this, as you can see, I kind of don't have space at all. So let's see, what's 9 take away 4 times -1 times positive 28. That's going to give me to 121. So therefore, t is equal to -3 plus minus 121 all over -2. Square root of 121 is equal to 11 in this case. So therefore, it's going to be -3 plus 11 is equal to -2, or it's going to be -3 minus 11 on -2. So just simplify that. So -3 plus 11 is going to give you 8. 8 divided by negative 2 is equal to negative 4. So t is equal to negative 4, or negative 3 minus 11 is equal to negative 14. Negative 14 divided by negative 2 is equal to positive 7. So therefore, our final answer, you only have to select the positive one because you can't have negative time. So it's going to be 7 seconds, and always include the units in your final answer. For question 15, this is going to be another projectile motion question. It wants us to sketch the graph this time. So in this case over here, we've got the 2p as 20 and 800. Okay, and now to find out what the y-intercept is, we'll start in d, or x in this case over here, is going to be equal to 0. So it's going to be h is equal to negative 2, 0 minus 20 whole square plus 800. Negative 20 whole squared is equal to 400. 400 times by negative 2 is equal to negative 800. And therefore negative 800 plus 800 is equal to 0. So your height is going to equal to 0. So that's your y-intercept value. Okay, so that's going to be 0, 0. That would also imply that one of your x-intercept is also going to occur at the origin as well. So now to find out the x-intercept, what we'll do is we'll sub in h, or y in this case is equal to 0. So if you do this, then it will be negative 2 d minus 20 whole squared plus 800 is equal to 0. Move the 800 to the other side. So therefore, your equation will look like this. Divide both sides by negative 2. So if you do this, then you'll have 400. And what we'll do now is we'll take the square root of both sides. So if you do this, it will be d minus 20 is equal to positive 20, or d minus 20 is equal to negative 20. What we'll do now is we'll add 20 to both sides to solve for d. Hence, d would equal to 40, or d is equal to 0. Okay, so therefore this is going to be another x-intercept. And now I'm just going to put where your your turning point is going to be. So it is therefore going to be, what's halfway? That's going to be 150. So therefore 750. So it's going to be somewhere around here. Okay, so therefore if you're drawing your graph, it would looks up. Sorry for my graph, because I'm using stars, it's just a bit hard to draw. So therefore this is going to be 20 comma, actually rub this out, that's just trash. Let's not do that at all. Let's redo. Let's model what a good graph should look like. So that's going to be 40, 20, and that should be over here. So let's try to draw this much better this time. And now, okay, so that's a bit better than previously. So now I'll add in the coordinates. Alright, sweet. So we're now done part A. For part B, you're trying to find the maximum height. So in this case, that's the y value of turning point. So it's going to be 800 meters. Kilometers in this case. So make sure you're looking at what the units is. So it's going to be kilometers. And in this case over here, my bad, it is meters. Okay, kilometers is for along the x direction, so it's going to be meters, and that's provided over here as well, as you can see. And it says find the distance between the launch site and the target. So in this case over here, this over here is the launch site, and your target is over here. So therefore it's essentially asking for the x-intercept. So therefore your answer is going to be 40 kilometers. This is the end of this video over here. Hopefully this particular solution video will actually help you guys with your own revision. I'll see you guys again in the next video. Bye.